if it keeps going. Yeah, so you can pause if you need.
Oh. Okay, class, so today we are going to discuss the partial quotients algorithm for division specifically. This strategy helps break down the process, especially with division problems using large numbers or when the divisor, which is this, does not go into the dividend evenly. So in this problem that we're going to work on, it's 195 divided by 12. 195 is our dividend, 12 will be our divisor. So we start by using easy multiples of the divisor to get our first partial quotient, which I'm going to separate. Our partial quotients will be on this side and our remainders will be on this side, using that line to divide them. So in this problem, 195 divided by 12, an easy multiple of 12 would be 10. So easy multiples, usually we would want to stick to hundreds, tens, fives, or twos. For this one, getting us closest to 195 would be 12 times 10 is 120. And then we subtract that just like you would a normal long division, so that is 75. And then here, the cool thing about the partial quotient strategy is if you know your 12 times tables, that's great. Some students aren't going to. Okay, class, so today we're going to discuss the partial quotients algorithm for division specifically. This strategy helps break down the process, especially with some division problems that use larger numbers or when the divisor does not go into the dividend evenly. So those words, this is going to be the dividend, what we're dividing, the number that we're dividing, and the divisor is what we're dividing by. So to start by... Okay, class, so today we are going to discuss the partial quotients algorithm for division. This strategy helps break down the process, especially with division problems that use larger numbers or when the divisor does not go into the dividend evenly. So to start, I just want to touch on those words. Your dividend is going to be 195 in this problem. That is what your is the number that you're dividing. 12 is the divisor, and that's what you're dividing by. So to start, we use easy multiples of the divisor to get our first partial quotient. And I'm going to put a line here to separate. Our partial quotients are going to go on this side, and our remainders will be on this side. So that's just an easy divider for us. So our easy multiples would usually be by hundreds, tens, fives, or twos. And in this case, we need to use probably tens because that's going to get us to a number close to 195. So I would do 10 times 12 is 120. And then you just subtract it like you would in a normal division problem. And then the next step is to get 12 into 75. So if you know your 12 times tables, we can guess maybe 5 times 12. That one's a pretty easy one, so we can get 60, and then we just continue down to until the dividend has been reduced to 0 or there's a remainder less than the dividend. So we'll just keep going. So 75 minus 60 is 15. So our remainder is still bigger than 12 in this case. So we would do 12 times 1 is 12, and then subtract that one more time. So our remainder is less than 12, which is what we need. And then on this side, we add up our partial quotients to get our quotient. So that's 10, 15, 16 with a remainder of 3. Okay, so we've got our answer here, 16 remainder 3. One thing I do want to touch on is we could have done this problem differently, which is the cool part about partial quotients. We could have, in this case, when we got our remainder of 75, we could have done 12 goes into 75 6 times, actually. So that could have been 72. Oop. Ignore that line there, did it at the wrong spot. And that, for us, just would have skipped this step right here. But it's cool because if you do not know that, it still gets you to the same answer at the end of the problem. So our quotient still would be, we would have just added 10 plus 6 and gotten 16 remainder 3 still.